In this lecture, we will study the effect of armature reaction in a synchronous generator if the armature current is unity power factor. Unity power factor means voltage and current, they will be in same phase. If you recall in our previous class, we have seen the effect of armature flux. In our earlier class, we have seen the effect of armature flux on field flux when the load connected with the armature winding was 90-degree lagging power factor load. So we will now explore it for unity power factor load. So let me copy this portion once more. This will be needed. So we are now going to find out the effect of armature flux on field flux for a synchronous generator operating at unity power factor. That means the power factor will be 1. So these are the three coils which is placed on the stator core, coil AA dash, BB dash and coil CC dash, and the induced EMF polarity in the coils AA dash, BB dash, CC dash is shown for this particular position of the rotor, which is shown on the which is shown in the diagram in the left hand side. Now what we are going to do, we will try to find out the rotor position for two different time instant. Okay, so let me mention, this is the rotor position, this is the rotor position, this is the rotor position when induced EMF, induced EMF in coil AA dash, in coil AA dash is maximum. So this is the rotor position. Likewise, we are interested in finding what is the rotor position when the current in the coil E dash is maximum. Now, why EMF induced in coil A dash will be maximum? Because you can see south pole is in front of coil side A and north pole is in front of coil side A dash. So that is the reason induced EMF in coil A dash will be a maximum. Now for this one, what we will do, I will just copy this thing like this. So this is the rotor position, this one. This is the rotor position when EMF, when current in coil A dash is maximum. So let me write this. This will be your south pole, this will be your north pole. These things are rotating in anti-clockwise direction. It is assumed that the prime mover is driving the rotor in anti-clockwise direction. We are assuming that because this being a generating action, in generating action you need a prime mover which will give the mechanical energy as the input. So prime mover will give the mechanical energy as input and the prime mover is driving the rotor in anti-clockwise direction. So what is this one? This is the rotor position. This is the rotor position when current current in coil AA dash is maximum. Current in coil AA dash is maximum. So what do we find here? That the rotor position is same for both these instants. So we can compare here, or let me place it in another way. So we can observe here these two, with these two diagrams we can observe that observe that rotor position is same. Observe that rotor position is same for both when induced EMF in coil A dash is maximum, when induced EMF when induced EMF in coil AA dash is maximum, and also number two, when current in coil AA dash when current in coil AA dash is maximum. For both the cases, same rotor position, because for both the cases, same rotor position both for both the cases, same rotor position, same rotor position. This is because power factor equals to 1. Power factor equals to 1. That means what? Unity power factor load is connected. That means we are saying unity power factor load is connected. So this is something which we should be able to realize it, because in the beginning itself it was said that your current is unity power factor. That means both voltage and current will be in same phase. Now what do we mean by this? That voltage and current will be in same phase. Voltage and current will be in same phase. This thing means that both the maximum of voltage as well as the maximum of current will happen at the same time. At whatever time instant the voltage is having its peak value, at the same time instant current will be also having its peak value. This is because we are assuming that power factor is 1. It is unity power factor load is connected with the armature winding. So that is the reason we are having the peak value of voltage and current. Both are happening. Both are happening means the peak value of voltage and current are happening at the same time, because it's a unity power factor load. The armature winding is connected with a resistive load. Resistive load means unity power factor load. That is the reason the time instant is same. I mean to say, at the same time instant, voltage is also having its peak value as well as the current. So that is the reason you are having the same rotor position. So up to this, it is clear. Now, what we are interested in, we are interested in finding the effect of armature flux on field flux. That means how armature flux is going to interact with the field flux. So for that, we can simply plot the magnetic lines of flux for field current and armature current separately. So by doing that, we will be in a position to conclude what is the effect. So for that purpose, let me again take up this diagram. We will again copy this diagram so that we can plot the magnetic lines of flux separately for current carried by the field winding and due to the current carried by armature winding. So over here we will plot the magnetic lines of flux. So the same drawing is again shown here, just so that the things are not getting clumsy. So these were the three coils AA dash belonging to phase A, PB dash belonging to phase B, CC dash belonging to phase C. So we are considering what unity power factor load. So let me mention here armature current unity power factor load is considered for synchronous generator. Let me write it. Unity power factor load. Unity power factor load is considered unity power factor load is considered for synchronous generator. Synchronous generator. So let us plot the magnetic lines of flux without making a delay. So first we will plot the magnetic lines of flux due to field current. So due to field current, the magnetic lines of flux we are going to plot like this. This is the magnetic lines of flux due to field current. So if you apply that right hand grip rule, you will find that this is the direction of the magnetic lines of flux due to field current. So you can now easily make out which is your north pole, which is your south pole. You can see here lines of flux are entering this pole face. So this will be your south pole. This is your south pole, and here the lines of flux are leaving. So this is your north pole, and the field MMF FF is acting in this direction. So this is the direction of FF. That is the field MMF. This is your FF field MMF. Now let us plot the magnetic lines of flux due to current carried by armature winding. So we will plot it. Now let me try to make up in this only, this region only. So this will be the pattern of the magnetic lines of flux due to current carried by armature winding. Let me plot it. This is the magnetic lines of flux due to current carried by armature winding. So now if you apply again that right hand grip rule, then you will find that lines of flux plot is like this for armature current IA. Now again I can mark the north and south pole formed due to the armature flux phi A. So this is your armature flux phi A. This thing is your field flux phi F. This thing is your field flux phi F. This is your armature flux phi A. Now where will be the armature MMF acting? FA. Armature MMF FA is acting along this direction. Yeah, along the direction of the magnetic lines of flux. Along the direction of the magnetic lines of flux. So this thing is your FA. So this FA is your armature MMF. Now you can easily make out that armature flux and field flux they are in magnetic space quadrature. Or even if you consider the orientation of field MMF and armature MMF in space, they are also separated by an angle of 90-degree electrical. So that means what the effect is cross magnetizing. So let me write these things over here in statement form. We are observing that we can observe from above, we can observe from above that orientation of phi f and phi a. Orientation of phi f and phi a in space is such that is such that they are placed in magnetic space quadrature. Placed in they are placed in magnetic space quadrature. Magnetic space quadrature. So therefore therefore the effect of armature flux, that means phi A, on field flux, that means phi F, is cross magnetizing for unity power factor load in alternator. Actually, it will be also valid for synchronous motor. For only unity power factor load, I am saying only unity power factor load. Also, you can observe. Also, It can be observed that. It can be observed that if F and Fa are separated in space, separated in space by 90-degree electrical. Since we are taking here number of poles 2, here number of poles equals to 2 na here, because some may think that why electrical and mechanical degree are same. So let me write here that in this diagram, in this diagram, number of poles, number of poles equals to 2. Hence, theta electrical equals to what? E by 2 into theta mechanical. Let me erase this particular portion. So theta electrical is P by 2 theta mechanical. So therefore both are same. Now I would like you to observe certain things. Is that since this is a generating action, so you can expect that electromagnetic torque will oppose the prime mover torque, right? So let us try to figure it out. What we will do, uh, I will keep this diagram in the next page, so that the whole thing is in front of us. Although the size may be reduced, so that I can write over there. So I will now elaborate on this. Let us do one thing. Let us place this north and south pole over here in this diagram. So let me bring over this diagram once more. So you can actually figure out that where the north and south pole will be developed on the stator core. You can see lines of flux are leaving here. Lines of flux are leaving this portion. Lines of flux are leaving. So this has to be your north pole. So this is your north pole, and here you can see lines of flux are entering. So this is your south pole. So you can place this north pole over here, south pole over here. Now what do you find? This south pole on the stator core and this south pole on the rotor core, they will repel each other. So you can just show it by some dotted line. Let me use some this pink color. So this thing will repel. This thing will repel. Let me keep it line like, and likewise this thing will get attracted. This thing will get attracted. Again, this thing will repel, and again this thing will get attracted. So I will write it over here. This is repulsion. This thing is repulsion. Repulsion. This one is attraction. South pole getting attracted by north pole on the stator core. So this is attraction. This is again repulsion. North pole repelling north pole. So this is repulsion. And this thing is again attraction. So what do you find here? That electromagnetic torque is developed in generating mode, but it is clearly acting in the clockwise direction. So you can it may be observed from the above, it may be observed from the diagram, it may be observed, it may be observed from the diagram. It may be observed from the diagram that electromagnetic torque developed, electromagnetic torque developed is acting in clockwise direction. Clockwise direction, and hence prime mover must overcome the counter, must overcome, hence prime mover must overcome, must overcome this electromagnetic torque, this electromagnetic torque developed so as to drive the rotor, so as so as to drive the rotor, in anti-clockwise direction. Anti-clockwise direction. So this is another important observation, interesting observation. You can find it out from this diagram. Is that from the diagram itself, it can be observed that electromagnetic torque is developed or is acting. Electromagnetic torque developed is acting in clockwise direction, and hence prime mover must overcome this electromagnetic torque developed so as to drive the rotor in anti-clockwise direction. Now, there is one more interesting point, is that if somebody asks you that by just looking at the diagram, can you tell me I mean to say, by looking at the phasor diagram, is it possible to tell whether the phasor diagram is drawn for a synchronous motor or synchronous generator? So this is also sometimes questions coming, that they will give you a phasor diagram, and by looking at the phasor diagram you should be able to tell whether the phasor diagram is drawn for a synchronous generator or it is drawn for a synchronous motor. So how to answer this kind of question? So for that we will again take the help of this diagram only. Unity power factor load I am taking. So let me copy this. Now let me reduce it a bit so that we can have other things written. So this is C dash. Now we are assuming that unity power factor load is connected with the armature windings. Okay, so let me write these things first so that you know what is our assumptions, or what we have taken. So what are the things? Number one is that unity power factor load is connected with armature winding. Unity power factor load connected with armature winding. Connected with armature winding. Number two, synchronous generating mode is assumed. Synchronous. Let me write only generating mode. We are dealing with synchronous machine only, so no need to write synchronous again and again. Generating mode assume. So we are assuming generating mode. So we can say that since unity power factor load is connected, since unity power factor load, unity means 1. Unity power factor load means that the value of power factor will be 1. So since unity power factor load is connected, unity, unity power factor load is connected, therefore, therefore what is going to happen? Therefore peak value of induced EMF, peak value of induced EMF as well as current, as well as current, as well as current happens at same time, happens at same time. This also means, this also means that the same rotor position, the same rotor position will correspond to, will correspond to time instant of, time instant of time instant of maximum EMF and maximum current. Let me write the word peak so that we are in synchronism. So time instant of peak EMF, peak value of induced EMF, peak value of induced EMF and peak value of induced EMF and peak value of current and peak value of current. So we have learned this in this lecture only, but I just reminded you that we are taking unity power factor load. So we will have the same rotor position corresponding to time instant when peak EMF is happening and peak current is happening. So this is that rotor position. Now, what is the orientation of field MMF in space? So field MMF is like this, which I am showing, drawing right now. You can apply right hand grip rule and you can figure it out easily. This is the orientation of field MMF. So this thing is your field MMF. Now where will be the armature MMF? Remember I told you that we will not take the MMF for the three coils separately. We will take the resultant MMF, and resultant MMF is aligned with the magnetic axis of that coil which is carrying the peak current. So who is carrying the peak current? Coil A dash has to carry the peak current because induced EMF in coil A dash is a maximum at this moment. So this is your FA. So over here we can say that FA stands for FA stands for armature MMF, not phase A. FA stands for armature MMF, and actually actually FA is the resultant MMF, is the resultant MMF due to current carried by due to current carried carried by coils of three phases A, B, C. Further remember, further remember that, further remember that, peak value of, further remember that resultant MMF, further remember that resultant MMF, further remember that resultant MMF is going to be aligned, going to be aligned with the magnetic axis of that coil, with the magnetic axis of that coil, magnetic axis of that coil, which is carrying the peak current, which is carrying the peak current, which is carrying the peak current. As according to diagram, coil A dash has to carry the peak current. According to diagram, according to diagram, coil A dash has to carry peak current, has to carry peak current because EMF is maximum in coil AA dash. So now we can find that FF and FA, these are the two MMF inside the synchronous generator. Obviously, there are two windings. What are they? Armature winding and field winding. So there will be one MMF corresponding to armature winding. There will be another MMF corresponding to field winding. So we are having two sets of MMF, isn't it? So now, how to find out that whether this is working as a motor or generator, isn't it? That question is still remaining. So let me again place this thing in the next page. So we are now going to observe one more point. What is that? That FF and FA are stationary with respect to each other because both are rotating at synchronous speed and in same direction. Okay, so this is another point which has to be thoroughly observed. Let me write in some another color. Observe that FF and FA both are both are going to rotate both are going to rotate at synchronous speed at synchronous speed and in same direction and in same direction. So we are saying that FF and FA both are going to rotate at synchronous speed and in same direction. Therefore, therefore, uh, they are stationary with respect to each other. They are therefore FF and FA are stationary with respect to each other. They are stationary with respect to each other. With respect to each other. They are stationary with respect to each other. Further, further, the space distribution, the space distribution, the space distribution of FF and FA, the space distribution of FF and FA are assumed to be sinusoidal, are assumed assumed to be sinusoidal, sinusoidal. So we can take them as space phasor. So we can we can consider FF and FA as space phasor. So this is the background work which I am doing. Now after justifying this, it's a child's play. You can take the resultant MMF. This is your FA. This is your FF. Let me write it. This is your FA. This is your FF. So what is the resultant MMF of these two? Obviously you have to draw a parallelogram. So we will draw a parallelogram. Over here, they are 90-degree apart, so that parallelogram will be a rectangle. So this thing is the resultant MMF. This thing is the resultant MMF. So what is this resultant MMF? Let us write this as FR. So what can we write here? That FR as a phasor is equals to phasor sum of FF plus FA. So FR is known as resultant MMF. FR is known as resultant MMF. This is known as the resultant MMF. Now, in which direction the rotor is rotating? In anti-clockwise direction. So obviously this MMF is rotating in anti-clockwise direction. This rotor is rotating in anti-clockwise direction. This is also rotating in anti-clockwise direction. This MMF. Because after peak of phase A, peak of phase B will happen. So FA will change its orientation. Listen it carefully. After peak of phase A, right now for this rotor position, peak of phase A is happening. After 120-degree rotation, peak of phase B will happen. So at that time, FA will be aligned with the magnetic axis of phase B. So that means FA is also rotating in anti-clockwise direction. So this will also rotate in anti-clockwise direction. So you can see here that FF is leading FR. So for generating action, we are going to find like that. I was saying in the question how to find out whether the synchronous machine is working as a motor or generator by just looking at the phasor diagram. So what I am saying, for generating action, what will happen? FF is going to lead FR. So this is what the ultimate thing is there, which we want to write here, that for generating action, for generating action, for generating action, F is going to lead, is going to lead FR. FR, FF I've already mentioned. What is FR? What is FF? FR is the resultant MMF. So for generating action, FF is going to lead FR. Now what is going to happen in motoring action? In motoring action, the direction of armature current will reverse. So thereby FA will reverse. So FR will reverse. And in that case, you will find that FR is leading FF. So I mentioned that also, that for motoring action, for motoring action, direction of armature current will reverse. Direction of armature current, direction of armature current, and thereby armature MMF, and thereby FA will reverse, will reverse. FA will reverse, and hence it can be shown for, it can be shown that, it can be shown that FR will lead, FR will lead FF for motoring action, for motoring action. So this is what is there. We can find it out from the phasor diagram itself, whether it is working as a motor or generator. Now, this particular angle between FF and FR is sometimes referred as load angle, given by the word symbol delta. So this delta is sometimes referred as load angle. Delta is referred as load angle. It is also referred as your torque angle or power angle. So I stop over here for today, but in my next class which I will take tomorrow only. I will let you know in the Google Classroom. I will take up the generalized phasor diagram for a round rotor alternator, generalized phasor diagram. So if you have any questions, you can ask me.